define conductance. For magnetic circuit, we define permeability. Those magnetic materials are made suited for making armature and transformer cores which have high permeability and low hysteresis loss. Reluctance S is defined as the opposition of magnetic flux in a magnetic circuit. Total number of magnetic lines of force in a magnetic field is called magnetic flux. Unit is Weber. Reluctance S is equal to ampere turns per Weber, AT per Weber, that is 1 upon Henry. Self-inductance, magnetic flux into current, that is equals to 2 millihenry in this example. The direction of DC and magnitude of current in DC do not change. Simply, both positive and negative terminals of a battery are always positive and negative. Therefore, the current that flows always in the same direction between both terminals. For example, fuel cells, batteries, and solar cells. This is due to fixed polarity. Here, Vrms is equal to 0.707 of maximum voltage. I average is the average taken of instantaneous current values. RMS stands for root mean square. This value of current is obtained by squaring all the current's values, finding the average and then square root. That is, effective value of current is RMS value of current. In a sinusoidal wave, I average is always less than I RMS. For a rectangular wave, I average is always equal to the IRMS. Therefore, heating effect is constant. The SI unit of magnetic flux, that is Weber or Tesla meters square, named after the German physicist Wilhelm Weber. EMF, electromotive force, the electric potential produced by either an electrochemical cell or by the changing of magnetic field. EMF as voltage. 1 volt is equal to 1 joule per 1 coulomb. A volt is a unit of EMF that measures the potential difference in electric potential between 2 points as voltage measured in volts. In BH curves, B stands for magnetic flux density, that is BH curve, hysteresis or magnetization curve. Graphical representation of magnetic property of material relating magnetic field strength H and the magnetic flux intensity or density, that is B. That is B is equal to flux per unit area, that is phi per meter square, that is 1 Weber per meter square is equal to 1 Tesla, and MMF is magnetomotive force. H is the magnetizing force, AM, ampere meter. Hysteresis curve, BH curve, is magnetic flux density, B lagging behind H, that is field strength. SI unit of actual permeability of free space is H, Henry per meter. Constant between B and H. Magnetic flux lines passes through iron because of the permeability of iron is much larger. MMF of Magnetic circuit is analogous to EMF in electric circuit and may be considered the factor that set up the flux. In BH curve of soft iron will not be a straight line. Soft iron is a ferromagnetic material that is commonly used in electromagnets and magnetic circuits due to its high magnetic permeability. It has a non-linear BH curve due to its high saturation magnetization. The direction of induced EMF can be found out from Fleming's right-hand rule. Len's law suggests that the direction of induced EMF opposes the change in magnetic flux. The negative sign in Faraday's law can be relating to it is equal to minus n d phi by dt. Len's law gives the direction of induced EMF with respect to change in magnetic flux, but Fleming's law gives the direction of induced EMF more accurately. Soft iron has the least hysteresis loop area because it has low coercivity and high permeability. Hysteresis loop area is a measure of energy loss in a ferromagnetic material when it is repeatedly magnetized and demagnetized. I is equal to Q upon T, that is coulombs per second, and V is equal to J upon Q, that is joules per coulomb. Q is equal to IT, and permeance is reciprocal of reluctance. Conductivity of a metallic wire is its ability to allow the electric charges or heat to pass through it, and analogous to permeability, which is the measure of magnetization produced in a material in response to an applied magnetic field. Scientist Heinrich Rudolf Hertz was a German physicist who first conclusively proved the existence of the waves, which are electromagnetic, and was predicted by James Clerk Maxwell's equation of electromagnetism. The unit of frequency is cycle per second was named Hertz in his honor. Frequency is equal to cycle per second is equal to Hertz. Frequency of a wave is the number of waves that passes a point in a certain period of time, that is in 1 second, that is number of cycles in 1 second is equal to frequency. Power factor of an AC circuit is equal to the cosine of the angle between voltage and current. If two sinusoids of same frequency but different amplitude and phase angle are added or subtracted, the resultant is a sinusoid of the same frequency. Peak factor is equal to ratio of maximum value to the RMS value, and that is equal to 1.414, and form factor is ratio of RMS value to the average value, that is equals to 1.11 for sinusoidal waveform. These are the constants for designing the electrical equipments. In an AC circuit, power is dissipated in resistance only due to voltage drop in resistance. The voltage of domestic AC is 220 volt. It is the RMS voltage of supply. Cos 0 is equal to 1. Therefore, power is VI cos phi, that is equal to VI for resistive load, and for inductive and capacitive load phi is 90, that is phase angle between voltage and current is 90. So cos phi will be 0, therefore power will be 0. So consumed power is always 0 in inductive and capacitive load. Power is Vi cos phi, therefore 1840 watts. For purely inductive and purely capacitive circuit, the power factor is 0. The true power equals to 0, that is P is equal to 0. Maximum flux density is equal to phi upon A. So therefore 6000 microtesla. Magnetic circuit have an equivalent to the potential difference of electric circuit. This is the magnetic potential difference which allows us to apply Kirchhoff's law to the magnetic circuit analysis. This is the phasor representation of three-phase voltages. VR as a reference and VB will be the plus 120 or minus 240, and Vy is equal to minus 120 and plus 240. So these are the leading and lagging phase angles between VR, VB and Vy. So the phase sequence is ABC. The maximum value of voltage in sequential order is ABC. This is the three-phase, three-wire system. This is three-phase, four-wire system with neutral. Resistance is not charging or storing element, so applicable to AC and DC also. Capacitive reactance Xc is equal to 1 upon 2 pi Fc. Therefore, Xc is inversely proportional to frequency. As the Xc decreases, the frequency will increases, and XL, that is inductive reactance 2 pi FL, XL will directly proportional to the frequency. XL increases, then the frequency also increases. The pure inductive circuit stores energy in magnetic field and again returns to the source and do not consume power. P is equal to Vi cos phi, and Vi cos of 90 degree is equal to 0. Power is 0. So in the one cycle, T is denoting as a time period of a one cycle, and frequency is the reciprocal of time period. So this is cosine waveform and this is sinusoidal waveform. The phase difference between these two waveforms is 90. An air gap is inserted in magnetic circuits to prevent saturation and to reluctance increment of a magnetic circuit. By inserting air gap or another non-magnetic materials like a fiber plate, thereby increasing amount of current that could put in the coil before we reach saturation. Also, the air gap helps the magnetic flux to expand outside the magnetic circuits. The magnetic effect of current was discovered by Oersted by showing electricity and magnetism were related phenomena. So in this waveform, reference is voltage and current is lagging behind by 30 degrees. So current lags V by 30 degree and voltage leads current by 30 degrees. And in this waveform, current leads voltage by 60 degree and voltage lags current by 60 degrees. And this is the in phase waveform. Voltage and current are in phase. This is applicable for the resistive load. These are the circuit diagrams and phasor diagram for resistive circuit and purely inductive circuits and purely capacitive circuits. In resistive circuits, you can see voltage and currents are in phase, and in purely inductive circuits, current is lagging behind by 90 degree, and in purely capacitive circuits, current leads voltage by 90 degree. due to all impedances are not equal, therefore unbalanced star load, then all values will be unequal. If 8 plus J6 for all loads, then balanced star load, then all values will be equal. This is for balanced, and this diagram shows for unbalanced star load. For the conversion of star to delta, that is resistance between B and C is equal to resistance of B plus resistance of C plus resistance of B into resistance of C upon resistance of A. This is the circuit analysis for star and delta. So the equivalent resistance across X and Y is 2.38 ohm. Delta connection, that is mesh connection, is that closed loop which is planar, and this is resistance between A and B is equal to 29 ohm. In delta connection, VL is equal to VPH and IL is equal to root 3 IPH. In star connection, VL is equal to root 3 VPH and IL is equal to IPH. So here L is stands for line and PH stands for phase. A generator having two or more electrical windings which are separated by equal electrical angle generates a polyphase electrical system. The electrical angle or displacement depends upon the number of windings or phases. In three-phase system, the generated voltages are separated from each other by 120 degrees. So the total summation of this voltage is always 0. That is vector addition. Voltage between free ends to line is VL, and voltage between across each coil to phase voltage. Inside magnet, the field lines moves from south to north pole, and outside magnet north to south pole. The direction of rotation of electric motor's coil is determined by the Fleming's left hand rule. We can induce the current in the coil by moving the coil in a magnetic field. We can have addition and subtraction in the rectangular form directly, and angular frequency, that is omega, is equal to 2 pi f radians per second. So here angular frequency is 31.4 radians per second. The sine wave is said to be lagging because it passes through the zero following the other. Hence, it crosses zero after the first wave. Therefore, it is said to lag. The time axis while measuring an AC sinusoidal voltage or current represents the phase angle when converting it into a phasor, that is magnitude and angle, phase angle. Here 6 is the magnitude of voltage and phi is the angle between this reference and 6 voltage or current values. The length of the phasor arrow represents the magnitude of the quantity, whereas the angle between the phasor and reference represents the phase angle. Ohm's law, V is equal to IR, that is analogous to force is equal to flux and reluctance. For magnetic circuits, MMF is decreased directly proportional to decreased magnetic flux, whereas S is constant. So force is 1580. Phi is equal to BA. B is equal to phi upon A, that is 1.6 Tesla. DC generator generates electricity using the principle of Faraday's law of electromagnetic induction. When a conductor is placed in a varying magnetic field an EMF induced in it. According to Faraday's first law of electromagnetic induction, an EMF induced in a conductor when it cuts the magnetic flux of a magnetic field. If the two ends of a conductor are connected to an outside circuit, the induced EMF causes current to flow in the circuits. According to the Faraday's second law of electromagnetic induction, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linkage, that is E is equal to minus n d phi by dt. D phi means that is change in magnetic flux with respect to time, and n is the number of turns of windings. A minus sign is denoted for the Lenz's law for direction of induced EMF, that is opposite to the very cause for the production of induced EMF due to this changing magnetic field. The law of conservation of energy, that is mechanical to electrical, that is dynamo, and electrical to mechanical, that is motor. The induced EMF persists only as long as the change in magnetic field continues, and polarity of the induced EMF is given by the Lenz's law. Ampere's law correlates with the magnetic field induced in the coil. By-Savarit's law describes the magnetic field generated by a constant electric current. Fleming's right-hand rule gives the estimation, that is, in which direction the current will flow. Galvanometer measures the amount of induced current flowing through the circuit. If a current carrying conductor connected to a battery, the pointer of galvanometer fluctuates and points to the amount of current flowing. Self-inductance of a coil is said to be 1 Henry if an induced EMF of 1 volt is set up in it when the current in it changes at the rate of 1 ampere per second. It is the induction of voltage in a current carrying conductor when current in the conductor itself is changing, that is as L is equal to 1 Henry when 1 voltage is set up due to the changing in current 1 ampere per second. Self-induction of a coil tends to take care of the magnetic field linked with it and opposes any change within the flux by inducing a current in it. Therefore, it is called as a inertia of electricity. Electrical machines, Unit 2. A transformer is a device used to convert low alternating voltage to a high alternating voltage and vice versa. A phenomena of mutual inductance occurs in transformer consisting of a soft iron coil with two coils wound around it, which are not connected to each other. A transformer does not work on DC and operates only on AC. Therefore, it step up or step down the level of AC voltage or current by keeping frequency of the supply unaltered. On the secondary side, it varies the input voltage. There are two types of losses in a transformer, that is copper loss and core loss. Transformer rating is in kVA, not in kW. Due to copper loss, I square R depends on current and iron loss depends on voltage, therefore in kVA. In two-winding transformer, there is no electrical connection between primary and secondary, so the power is transferred through induction. But in auto transformer, there is a common electrical path between primary and secondary. So power is transferred through both conduction and induction process. In case of parallel field connection, it won't rotate at all and will start humming and will create vibration as a torque produced by positive and negative cycle will cancel out each other. DC shunt motor will be heated up and it may burn. If EB back EMF vanishes suddenly, motor circuit will try to retain back EMF by drawing more current from supply. If supplying unit didn't trip down by this time, excess current in armature may heat up and the armature causing to burn. In case of DC motor, the speed is directly proportional to back EMF. So, with increase in speed, the EB also increases. Therefore, armature current is also decreased. In case of series, armature current is equal to line or load current. All other parts except brushes and commutator are same in AC machines when other outer looks are only taken in considerations. Commutator is used only in DC machines for providing mechanical rectification and not in AC machines. Fleming's law can be summarized as whenever a current carrying conductor comes in under a magnetic field, there will be a force acting on the conductor, and on the other hand, if the conductor is forcefully brought under a magnetic field, there will be an induced current in that conductor. In both DC motor and DC generator torque equations, we know that the current drawn is directly proportional to the torque required by the machines, that is, T is directly proportional to I. Nameplate of motor shows rated values, that is speed, current, voltage, and also output power available at shaft when all other quantities are set to related rated values. When supply voltage is increased, full load current will decrease in order to keep output power constant, which will decrease torque at that moment, while starting torque will remain as it is irrespective of any change in supply voltage. Main parts of DC motor: stator, rotor, yoke, poles, armature and field windings, commutator and brushes. The universal motor is used for purposes where speed control and high values of speed are necessary. The various applications of it are portable drill machines, hair dryer, grinders, table fans, blowers, polishers, and kitchen appliances. For example, mixer. Field winding, concentrated type, is mounted on a silent pole on the stator, and the armature winding, distributed type, is wound in slots on a cylindrical rotor. On some extent, copper brushes, that is carbon brushes, can act as a self-lubricating brush. On moment polishes the commutator segments. Damage to the commutators is less when copper brush are used to on occurrence of spark over. The function of yoke is that it protects the entire machine from the dust and dirt. It also provides mechanical support for the magnetic poles. It acts the return path for the magnetic flux. Commutator converts AC to DC output as mechanical rectification, also conversion of electrical to mechanical energy. And in AC machines, no need of rectification process. Electromagnets is more powerful when its mmf is high. At full load condition, field winding contains maximum ampere turns. Hence, it is most powerful electromagnet in a DC machine. At no load, armature current tends to zero. Flux tends to zero, where speed is inversely proportional to the flux and speed will tends to infinity. Thus, at no load, speed of DC series motor is highest. A separate power supply is provided to field in separately excited DC motor. Compound motor shows combined effect of shunt and series field windings. Differential compound series motor gives low starting torque examined by torque current characteristics. Hence, applications of low starting torques are differential compound motors. Universal motor is a special type of motor that can run on DC supply or a single phase AC supply. Since it can run both on AC and DC, therefore it is called as a universal motor. Brushed universal motors are largely independent on AC frequency. DC series motor can operate on DC and AC. It is a universal motor, but DC shunt motor can only operate on DC because of pulsating torque in AC. Domestic pumps, traction systems, and lifts can use electric motors. They often require specific type of motors that are tailored to their specific requirement, such as induction motors, synchronous motor, or specialized DC motors. Transformers used with a AC ammeter, that is CT. Current transformers used to extend the range of an AC ammeter. It is set up to step up transformer, that is CT. Current transformers. Transformer core experiences eddy current losses when transformer is in the operation. In order to reduce eddy current losses, it is advisable to use large number of sheets laminating from each other or stick together than using single block. The purpose of transformer core is to provide low reluctance path. Universal motor is DC series motor with AC supply with smaller torque, so it can be used for lower torque applications. Stepper motor has a cylindrical permanent magnet rotor, thus it does not contain windings, commutators, or brushes mounted on it. Stepping motors motions is in the form of steps and is an incremental device in which as the time increases the steps are increased and used as a DAC, digital to analog converters. Stator parts of a motor is the stationary part of the motor, and rotational speed of a given stepper motor is given by the step pulse frequency. In an induction motor, the rotor is powered by electromagnetic induction from the stator, eliminating the need for the separate power source. Stator carries the windings that create RMF, rotating magnetic field, which interacts with the rotor to produce motion in an electric motor. Single phase induction motor are widely used in household applications due to their simplicity, low cost, and reliable performance. Speed of the DC motor is determined by the back EMF generated in the armature coil, which opposes the applied voltage. DC series motor provide high starting torque due to their characteristics of high armature current and strong field interaction. DC motors are suitable for variable speed control applications as their speed can be easily adjusted by controlling the input voltage or current. Ceiling fans uses single phase induction motor due to their cost effectiveness and reliable performance. Stepper motors used in CNC machines and 3D printers are commonly used in robotics and precision control applications also due to their ability to move in discrete steps and hold position without the need for feedback. Electric motors, single phase induction motor for household washing machines and electric pumps, and brushless DC motors are suitable for high speed applications due to their ability to operate at high rotational speeds and provide precise speed control. Electric bicycles or cars efficiency is greater, compact size, and assist at various speeds. Robotic vacuum cleaners often use stepper motors for precise control of movement and positioning. Universal motors have lower efficiency compared to other motors types due to the energy losses associated with their universal commutators. Electric fans often use synchronous motor due to their ability to operate at constant speed and maintain synchronization with the power supply frequency, that is synchronous motor. Stepper motors have a limited speed range compared to other motor types, which can be a disadvantageous in certain high speed applications. Electric drills and power tools often use universal motors due to their high power to weight ratio and ability to operate on both AC and DC power sources. The purpose of a transformer core is to provide low reluctance path for a magnetic flux linking primary and secondary windings. In doing so, the core experiences iron losses due to hysteresis and eddy current flowing within it, which in turn shows themselves as heating of the core material. Every transformer is designed for use it for multiple years. Thus, transformers are designed to handle the problems on site itself because it saves time but also makes repairing work easy. Primary and secondary windings of a step up and step down, that is step up less and step down high, and more and less windings depending on the number of turns with respective windings respectively. So for the step up transformer, secondary windings are more, and for step down transformer, secondary windings are less in turns. Dish washers and washing machines used in induction motor for reliability, low maintenance, and ability to handle variable loads. Cumulative wound DC motors give high starting torque like a series motor, and reasonable good speed regulation at high speeds like a shunt DC motor. As these type of motors offer the best series and shunt motor, it is practically suitable for most common applications like elevators. A differentially compound DC motor flux reduces so sharply at small increase in load at higher values of loads. It is advisable that motors should not be used beyond some load values, as it may damage itself by self-loading. In differential compound motors, series field opposes shunt field. It has poor starting torque as the resultant flux is minimized by this opposition. The flux starts decreasing with increase in load, causing the starting torque to be less than any other DC motor. We can't use DC series motor as our load is almost zero at some points. Thus, we will use compound motors which can work on no load. Also, cumulative compound motors is provided with flywheel so that this machine can deal with peak values. The direction of rotation of universal motor can be reversed by reversing flow of current through either armature or field windings. Universal motor is DC series motor with AC supply with smaller torque, so it can be used for lower torque applications, that is vacuum cleaners, table fans and portable drilling machines. The external characteristics of a differential compound motor have minimum voltage for the high current voltages. This is the best harnessed feature for a high current requirement by the arc welding applications. The instantaneous values of flux, that is phi t, is constantly changing and is not a useful value to consider for the EMF equation of a transformer. Therefore, the values of flux involved in the EMF equation is maximum value of flux, that is phi m. The key performance specifications for sourcing a stepper motor are voltage, speed and torque, rotor inertia and step angles, also mechanical motion, inertia load and speed requirement. A stepper motor is a brushless DC electric motor whose rotor rotates in discrete angular increments when its stator windings energized in a programmed manner. They have multiple coils that are organized in groups called fluxes. By energizing each flux in sequence, the motor will rotate one step at a time. It is an electromagnetic device which converts the electrical pulses into discrete mechanical movements. The shaft of the electrical motor. The life of the motor depends only upon the life of bearings. Wide range of rotational speeds are possible and due to brushless it is reliable. Variable magnet is not the type of a stepper motor. Variable reluctance stepper motor consists of a soft iron multiple tooth rotor and a wound stator. Permanent magnet stepper motors have a rotor made up of permanent magnets. Hybrid stepper motor provides better performance with respect to step resolution torque and speed. Stepper motor is a good choice whenever control moment is required. They can be used in the applications where there is a need to control rotation angle, speed, position, and synchronism. Due to all these reasons, it is used in many different applications. The permanent magnet stepper motor has low cost and low resolution type motor with the step angle of 7.5 to 15%. This type of stepper motor has a rotor made up of the permanent magnet. The other motors mentioned in the option do not have low cost as well as low redundancy. Speed is not the main selection criteria of the stepper motor. The selection criteria includes resolution required, drive mechanism component, operating pattern such as sequencing, acceleration, and torque requirement. Step angle is given by 360 into pH upon NPH, where NPH is the number of equivalent poles per phase or number of rotor poles. pH is the number of phases and N is the total number of poles in all phases. Torque in case of linear magnetization of DC series motor is directly proportional to the square of the armature current, that is T is directly proportional to the Ia square. So armature current is made half of the original value, then torque will be 1/4 of the original value, that is 25% of the previous value. The outer frame of a DC machines is called yoke. It is made up of cast iron or steel. It not only provides mechanical strength to the whole assembly but also carries the magnetic flux produced by the field windings. In DC shunt machine, the armature resistance is low and field winding resistance is high. An electric generator works on the principle of dynamically induced EMF of electromagnetic induction. In transformer, the winding is tapped in the middle of for voltage regulation and eliminate axial forces. The maximum efficiency of a transformer is defined at that value when copper loss is equal to iron loss. In all other cases, the efficiency will be lower than the maximum value. Power transformers are operated on full load, hence have maximum efficiency at full load in design. Iron core of a transformer is laminated to reduce eddy currents. Eddy currents are the small currents that results from the changing magnetic fields. The working principle of motor is Fleming's left-hand rule. It states that when a current-carrying conductor is placed in a magnetic field, it experiences a force. The direction of force can be determined by Fleming's left-hand rule. CPR, counter per revolution, with respect to moment of motor. Two square pulses are generated at a time by a typical motor encoder. CPR is the one number of quadrature code decode that states exist between these two square pulses. AC motors do not have brushes for having longer life expectancy. DC have brushed and brushless BLDC motors. The breather is used in the transformer to filter out the moisture from the air. The leakage flux depends on load current, independent of voltage, frequency, and power factor. An ideal transformer should have a infinite resistance between primary and secondary winding. However, the resistance may be in order of giga-ohms or tera-ohms depending on the insulation between the primary and secondary winding. High voltage winding always has a large number of turns as voltage is directly proportional to the number of turns. An auto transformer can be both a step up and step down transformer. It has single winding that is shared by both the primary and secondary circuits. This means that the auto transformer can be used to either increase or decrease the voltage depending on how the windings are connected, that is both electrically and magnetically coupled primary and secondary windings in one magnetic core. Auto transformer is used as switch. It is used for voltage correction and variac also. The main disadvantages of auto transformer is that no electrical isolation between primary and secondary windings. If primary windings may damage, the whole auto transformer may fail, and individual earthing of winding is not possible. For a given transformer rating, as the frequency increases, the product of window area and cross-sectional area also of the limb decreases, which means iron required for the core decreases. Therefore, frequency increases, the transformer becomes lighter and smaller in size. Copper in auto transformer and two winding transformers is equal to 1 minus T2 upon T1. This means auto transformer required less copper, hence transformation ratio K approximately equals to 1. Then copper saving is good and copper loss is less. In auto transformer, single winding as primary and secondary both. Thus, taking the appropriate winding into consideration, a variable secondary voltage is obtained. Thank you. Electrical Machines, Unit 2. Electrical Safety and Protective Devices, Unit 3. MCB, Miniature Circuit Breaker works on magnetic effects of electric current. When there is a flow of electric current, it creates a magnetic field that repels the magnet present in the switch. This repulsion breaks the circuit and restricts the flow of current. Standard color for AC supply ground is green in India, red for live phase wire, RYB, red, yellow, blue, and black for neutral. Electrode connected to the main is basically a source of EMF conducting material that is used for connecting electrical machinery to the earth is known as earth electrode. In occurrence of any leakage current due to the pure shielding of the apparatus, the earth electrode is used to provide a very low resistance path from the electrical appliances to the earth. Resistance is measured to check it in good or bad condition of it. Earthing can be used to maintain a constant line voltage. In a three-phase system, this is achieved by earthing the neutral. Spike voltages occurring as a result of lightning or any other fault can be dissipated to ground by earthing, thus protecting the equipment. After earthing, the various parts of electrical machines such as casing, armoring of cables, etc. are at zero potential, that is ground potential. They possess very low resistance. Specific resistance depends on the nature and properties of the material. Specific resistance is different for various types of soils such as dry, rocky and wet soil. When the insulation fault arises, earthing helps to prevent the risks of fire hazard. Earthing helps to prevent leakage of current and avoid shock, to safeguard all the equipments connected to the earth while operating. Time required to blow out is fuse depends on value of fault current. The greater the fault current, the smaller time taken by the fuse to blow out. Fusing element of 10 ampere current is lead and tin because it attracts more current. Fusing factor is always greater than 1, that is it is the ratio of minimum fusing current to the current rating of the fuse and is measure of how quickly a fuse will melt or blow when subjected to an overcurrent condition. BJT, bipolar transistors, is a type of a solid state switch having no moving parts and no physical contacts, which is why they are called so electronic switch. Earth resistance is dependent on depth of the earth electrode in earth, size of earth electrode and earth wire and temperature of soil surrounding the earth electrode. In case of HRC fuse, a current carrying element is surrounding by quartz powder to quench the arc. The combination of fuse and switch is called as SFU unit, that is switch fuse unit, which is stationary, and FSU, that is fuse switch unit. It is not necessary to change a MCB after tripping. A current flowing from live point of AC supply to earth is called as leakage current. ELCB, earth leakage circuit breaker, is used for preventing electric shocks. MCB provides protection against short circuit, overload and earth fault. Length of earthing electrode is about 2.5 meter. Green and yellow striped wire is also not used to indicate 220 volt AC supply live wire. It is used to denote ground wire of an AC supply as earthing wire. Live and hot wire carry supply voltages of red color for both names same. A fuse protects a system or equipment from overload and short circuit faults by cutting off the power to them. Fuses are always connected in series with the circuit to be protected from excessive current. When the fuse blows, it will open the entire circuit and interrupt or stop the flow of current through the circuit. The primary use of an electric fuse is to protect electrical equipment from excess current and prevent short circuit or mismatched loads. Apart from protecting equipment, they are also used as safety measures to prevent any safety hazards to human. Fuse is defined as an electrical safety device that provides overcurrent protection to the functional electrical circuit. The melting point of a piece of wire called as a fuse is low, which means it melts and breaks when the temperature rises above its melting point. The fuse wire is always connected in the live wire of the circuit, because if the fuse is put in the neutral wire, then due to excessive flow of current, when the fuse burns, current stops flowing in the circuit, but the appliances remains connected to the high potential point of the supply through the live wire. Digital multimeter for measurement of AC voltage, current and resistance. Is it also for DC current, voltage and resistance, and or all several ranges. Current is passed through a low shunt resistance and is converted to voltage. AC quantities are converted to DC through various rectifiers and filter circuits. Voltmeter and ammeters are for measuring voltage and current respectively. Quantities such as current, voltage, and resistance are digitized by making use of an AD converter, that is analog to digital converter. They are then displayed on screen by making use of a digital display. Analog multimeters are less affected by electric noise and isolation problem. As a result, don't require power supply. Digital multimeter gives an electrical signal as output. AD converter for analog to digital signal conversion. This can be used for interfacing with external equipment. Usually, dual slope integrating type ADC is preferred in multimeter. It basically consists of several AD converters, counters, and attenuation circuit. Constant current source is used to measure resistance in a digital multimeter. Standard known value of current is passed through an unknown resistance, and the drop in voltage across resistance is measured. Rectifiers and filters circuits with various configurations are employed for measuring AC voltages. AC is converted to DC and is applied to the AD converters. Copper tungsten alloy is commonly used for making the arc of circuit breaker. Tungsten has an advantage, that is, it has a very high level temperature resistance, whereas copper provides an excellent conducting property. ELCB directly detects current leakage and directs it to the earth from the circuit and breaks the circuits. The rated current of MCB is less than 100 ampere. Connecting electrical machines to earth, general mass of it, by making use of a conducting material with very low resistance is known as earthing. Multimeter is a portable multi-range instrument used for measurement of current, voltage and resistance. Front panel of digital multimeter consists of display panel, selector switch, common input connector. If a short circuit occurs anywhere in the wiring system, excessive current flows through the wire and fuse, and if fuse operates properly, it will melt, cutting the current before any harm can be done to the connected equipment or circuit. MCB type B trips at 3 to 5 times rated current, suitable for resistive or slightly inductive loads. Type C trips at 5 to 10 times rated current, suitable for moderate inductive loads. Type D trips at 10 to 20 times rated current, suitable for loads with a high inductive components. ELCB, earth leakage circuit breaker. and RCCB, residual current circuit breaker, works on the KCL principle, that is, summation of all the currents at a node should be zero. At the event of earth leakage, current finds the earth path. Hence, imbalance occurs between the line current and neutral current. The coil in toroidal transformer senses residual current, which connected to relay. Earth tester's resistance measurement should not be more than for household 5 ohm, power station 0.5 ohm, measure station substation 1 ohm, minor substation 2 ohm. Thank you. Special purpose diodes and their applications. Unit 4. Sudden increase in current in a Zener diode is due to the rupture of the many covalent bonds present. Therefore, it should be connected in reverse bias. Semiconductor diode can be used as a rectifier. The function of the rectifier is that it converts an AC to DC by allowing the current to pass through in one direction. Rectifier first converts power to AC, then use a transformer to change the voltage, and finally rectifies power back to DC. Zener diode can be used as a regulator shunt to regulate the voltage across small circuits. They are always operated in a reverse bias condition. Forward biasing of PN junction offers low resistance. In case of an ideal PN junction, the resistance offered to 0. So forward biasing does not offer any resistance. R is equal to 0. Reverse current is mainly due to the drift of charges. It is due to the carriers like holes and free electrons passing through a square centimeter area that is perpendicular to the direction of flow. A PN junction diode can be used as a rectifier. During the positive half cycle, the diode is forward biased and allows current through it. In PN junction with no external voltage, the electric field between the acceptor and donor ions is called a barrier. The potential barrier created throughout the PN junction is due to the diffusion of electrons and holes, and this potential barrier normally does not allow charging flow through the junction, fixed donor and acceptor ions. When reverse bias decreases, the depletion region width decreases. As D increases, the capacitance increases. In a reverse bias diode, the current is very low, typically in the nano ampere to picoampere range. This is because the reverse bias causes the to widen, making it difficult for current to flow across the diode. The diode acts as an insulator in the reverse bias condition. When the voltage increases up to around measurable current starts to flow through the diode in the forward direction. As the voltage moves a little above, the current through the diode rises rapidly. Reverse bias applied to a PN junction diode raises the potential barrier because p-type material connected to the negative terminal and pulls the holes away from the junction. Similarly, n-type material connected to the positive terminal and pulls the electrons. Diode is a combination of p-type and n-type semiconductors. This combination creates a potential barrier at the junction. Therefore, the external power source must overcome the potential barrier to conduct. In the forward bias, the diode conducts, and in the reverse bias, it will not conduct. In forward biasing, the p-type is connected to the positive terminal and N-type is connected to the negative terminal of the battery. PN junctions are called diodes because they allow the flow of current in the one direction and not in another. They are two terminals or distinct electrodes which are A anode and K cathode. Anode A is a positive terminal in a forward biased PN junction diode. That P type is linked to positive terminal and N type is connected to the negative. On this type of this junction, the cathode K terminal is negative. Anode is a positively charged electrode or wire that charges the PN junction with holes. We call the lead affixed to semiconductor the cathode. Therefore, the cathode is the negative side of a diode. Conventional flow of current is from P side to N side. As in the forward bias PN junction, the electrons move from N side to P side, hence causing the conventional current flow from P to N. Conventional current flow is always opposite to the direction of electron flow. We can identify the positive and negative leads of a diode by using a color coding or and color band. A PN junction diode is often referred to as a one-way wall because it allows current to flow in one direction only. When a diode is forward biased, it conducts current, but when it is in reversed biased condition, it effectively blocks the flow of current. Germanium has a potential barrier of 0.3 eV and silicon has 0.7 eV. The reverse saturation IS or maximum I0 current during reverse bias of a PN junction diode depends on temperature, doping level, physical size of the junction. There is a series resistors connected to the circuit in order to limit the current into the diode. It is connected to the positive terminal of the DC. It works in such a way the reverse bias can also work in breakdown conditions. Zener diodes are called as voltage regulators, but they aren't called voltage regulators. They are called breakdown diodes since they operate in breakdown region. Zener diode has an incremental resistance, dynamic resistance, and the value of resistance is the inverse of the slope of the current and voltage characteristics of Zener diode. Zener diode is a specifically designed diode to operate in the breakdown region without getting damaged. Because of this character, it can be used as constant voltage device. A Zener diode is heavily doped so that the breakdown voltage occurs at a lower voltage. If it were slightly or moderately doped, it would break down at a comparatively high voltage and thus would not be able to serve its purpose. As the frequency of the incident radiations increases, the kinetic energies of the emitted electrons are higher and therefore requires more repulsive force to be applied to stop them. The value of saturation current increases as the intensity of the incident radiations increases. The value of cutoff potential decreases as the frequency decreases. Zener diode, once in the breakdown region, keeps the voltage in the circuit to which it is connected as constant. Thus, it is widely used as a voltage regulator. This is the symbol of Zener diode and normal PN junction diode. In normal PN junction diode, The breakdown takes place at avalanche breakdown, which is different than the Zener breakdown. Zener diode is specially made to operate in that region. Zener diode is fabricated by heavily doping both p and n side of the junction, which results in an extremely thin depletion layer or region. A light emitting diode LED is heavily doped. It works under forward biased conditions. When the electrons recombines with holes, the energy released in the form of photons causes the production of light. GaAs has an energy band gap of 1.4 eV. It can be used to produce infrared LED. Various combinations can be used to produce LEDs of different colors. A light emitting diode LED converts electric energy into light energy. A LED is a heavily doped PN junction which under forward bias emit spontaneous radiations. The semiconductor diode used for the fabrications of visible LEDs must at least have a band gap of 1.8 eV. The reverse breakdown voltage of LEDs are very low, typically around 5 volt. So, if SS voltage is provided, they will get fused. Semiconductors with band gap close to 1.8 eV are ideal materials for LEDs. They are made with semiconductors like GaAs, GaAsP, etc. LED works when the PN junction is forward bias, that is, P side is connected to the positive terminal and N type is connected to the negative terminal. In the current voltage characteristics of an LED, as the frequency increases, the voltage required to achieve the same current increases. Hence, it would have the highest wavelength. As the forward current is increased for an LED, the intensity of the light increases up to a certain maximum value. After that, the intensity starts decreasing. When the recombination of electrons with holes takes place, the energy is released in the form of photon. This photon is responsible for the emission of light. The warm-up time required should be lower so that the lightning action can take place faster. This is one of the advantages of LEDs over incandescent lamp. Electroluminescence is an electrical and optical phenomenon where material emits light when electricity flows through it. Little or no warm-up time is needed for light-emitting diodes. Aluminum alloys are used to obtain yellow, orange, red colors light. The sudden increase in current in a Zener diode is due to the rupture of the many covalent bonds present. Therefore, the Zener diode should be connected in reverse bias. Pure semiconductors are called intrinsic semiconductors. The number of electrons in the conduction band will be equal to the number of holes in the valence band. Intrinsic semiconductor are also undoped and I-type semiconductors. In substances such as gallium, boron, and aluminium are all trivalent atoms. These are called acceptors, impurities, and they produce p-type semiconductors. Therefore, germanium is doped with gallium in a p-type semiconductor diode. Holes are the majority charge carriers in a p-type semiconductor diode. These holes are actually electron vacancies that contain positive charge. The holes are responsible for the conduction in p-type semiconductors. A light emitting diode LED converts electric energy into light energy. A LED is a heavily doped PN junction which, under forward biased, emits in spontaneous radiations. The semiconductor diodes used for the fabrication of visible LEDs must at least have a band gap of 1.8 eV. Filtering is frequently done by shunting the load with capacitor. It depends on the fact that a capacitor stores energy when conducting and delivers energy during non-conduction. Throughout this process, the ripples are eliminated. The T is the total non-conducting time of capacitor. The charge per unit time will give the current flow. Therefore, the charge Q lost by the capacitor during the discharge time for shunt capacitor filter is IDC into T. Rectifier may be full wave or half wave. The capacitor filter are usually electrolytic capacitor even though they are large in size. The ripple waveform will be triangular in nature. The RMS value of this wave is independent of slopes or length of straight lines. It depends only on the peak value IDC upon 2 root 3. The presence of inductor usually dampens the AC signal due to self-induction induces opposing EMF or changes in the current. The inductor does not allow the AC component to pass through the filter. The main purpose of using an inductor filter is to avoid the ripples. By using this property, the inductor offers an infinite resistance to the AC components and gives a smooth output. Source of supply will be a battery, dry cell, or full wave rectifier, etc. Ripples are AC components and filters are used for eliminating AC components from a signal. Load regulation is the process of fractional changes of output voltage when the load current is increased from 0 to maximum value. Zener diodes in DC power supplies are used for producing a reference voltage used for comparison. Stability of Zener diode used in a importance factor in determining the stability of output voltage in DC power supply. Standard values of Zener diode voltage ZV are 5.1, 5.6, 5.8 is not standard value of Zener diode voltage, and 6.2 and 9.1. These are the standard values of Zener diode voltage. Deleting or neglecting 5.8 voltage. If the Zener diode of TC of about minus 2 millivolt is connected with a forward diode which has a TC of about plus 2 millivolt in series, the combination used to obtain a very low, that is close to 0 TC, uninterruptible power supply is used where load or temporary power failure can cause a great deal of inconvenience, UPS. When the supply is gone, the diesel engine is started, which runs the alternator, and alternator supplies the power to the mains. Non-rotating type UPS are not used anymore. Static UPS requires both inverter and rectifier, where rectifier to converters the DC from the battery to AC, inverter to charge the battery from mains. Usually, lead acid batteries are cheaper and have certain advantages over the other types. NC batteries would, however, be the best, but are 3 to 4 times more expensive than lead acid. UPS, uninterrupted power supply, is required for computers for backup. A very smooth output can be obtained by a filter consisting of one inductor and two capacitors connected across each other. They are arranged in the form of letter pi. So these are called as a pi filters. The capacitor offers a very low reactance to the ripple frequency. The CLC filters are used when high voltage and low ripple frequency is needed. Than L section filters, the capacitors in a CLC filter offers very low reactance to the ripple frequency. So maximum of the filtering is done by the first capacitor across the L section part. It offers zero resistance to DC component and high reactance to AC component, and L blocks the AC component which cannot be bypassed by the capacitors. The output contains, along with the DC components, the AC harmonics which does no useful work and reduces the efficiency. A rectifier is used to convert AC to DC, lower the AC, that is non-DC component in the output, lower are the ohmic losses. L has a very important property that current through it cannot change rapidly. We can make use of this property by connecting it in series. L filter offers impedance higher to AC and resistance lower to DC, such as the AC ripples do not pass through the load. AC ripples are not allowed to pass. By short circuiting the AC ripples, as the capacitor is always connected in parallel with the load, the capacitor charges when the low diode is in on state and discharges during the off state of the diode. The instant at which the conduction starts is called cut-in point. The instant at which conduction stops is called cut-off or cut-out point. The rectifier current is a short duration pulses which causes the diode to act as a switch. The diode permits charge to flow in capacitor. When the transformer voltage exceeds the capacitor voltage, it disconnects the power source when the transformer voltage falls below that of the capacitor. Since the rectifier conducts current only in the forward direction, any energy discharged by the capacitor will flow into the lead load. This results in a DC voltage upon which a superimposed a waveform referred to as a sawtooth wave. When p-type semiconductor is mixed with n-type semiconductor, p-n junction is formed. This is very small region which is in order of micrometer. This region is known as a depletion region. So thickness of junction depletion region is in order of 10 6 meter. In the depletion region of an unbiased p-n junction diode, there are only fixed ions where no mobile charge carriers are present. It acts like a barrier that opposes the flow of electrons from n side and holes from p side. Zener breakdown occurs where breakdown voltage is below 6 volt and avalanche breakdown occurs for other voltages. When biased correctly, Zener diode has a constant voltage across it. In depletion layer, an electric field exists that quickly sweeps out electron hole pairs that may be thermally generated and reduces the equilibrium concentration of the charge carriers to exceedingly low level. Under these circumstances, this region called the depletion layer behaves as an insulator. The two capacitors in addition with one inductor involvements, it provides filtering action. This leads to decrement in ripple factor. Low ripple factors means the ratio of current due to AC ripples and direct current is flow. Rectifiers electric device converts AC to DC by using one or more PN junction diodes, but output of the rectifier is pulsating, means contains both AC and DC components. Hence, to remove all the ripples of AC components from rectified output, we use filters. Ripple factor of LC filter remains constant with the load current. Commercial power supplies have voltage regulation within 1%. The DC voltage output is dependent on an internal voltage reduction transformer and should be matched as close as possible to the current required by the load. Typically, the output voltage will decrease as the output current to the load increases. If two similar 15-volt Zeners are connected in series, then 30 volt is the regulated output voltage. A low impedance allows the source to deliver current without significant voltage drop, ensuring the voltage remains stable even when connected to different loads. This is important for many electrical and electronic systems where a stable voltage is required for proper operation. A Zener diode utilizes reverse characteristics for voltage regulation. Zener diode begins regulation operation only when the input voltage is equal or more than Zener breakdown voltage. Otherwise, the diode remains off state. Due to the parallel operation with load, Zener diode are referenced as shunt voltage regulators. For Zener voltage less than 5 voltage, that is time constant is negative, and Zener voltage is greater than or equal to 5 volt, then time constant can be made 0. Zener voltage is greater than time, then the time constant is positive. ICs have been widely adopted by the industries over conventional Zener diodes as their betterment replacements for the voltage regulators. Thank you. Special purpose diodes and their transistors. Unit 5. BJT bipolar junction transistor. First transistor to be invented and widely used in circuit. There are three doped regions forming two PN junctions between them, that is NPN and PNP type transistors with emitter, collector and base doped. In a transistor, emitter is of heavily doped and moderate size. Collector is moderately doped and larger as compared to the emitter. Base is very thin and lightly doped. Emitter base junction of the transistor is forwards bias, while the collector base junction of the transistor is reversed bias, or vice versa, depending on the condition desired, which junction is forward or reverse biased. For transistor to be used as an amplifier, The emitter base junction is forward bias and base collector region is reverse bias. This state is called an active state. The total current entering the emitter, that is I, goes to the base form where the most of the current enters the collector and a very small fractions of current leaves the base. Thus, IB is less than IC. Since the emitter base junction is forward bias, their resistance is lower than the collector base junction, which is reversed bias. We know beta AC is equal to small change in IC upon small change in IB. Now at VCE is equal to 10 volt, we read two values of ICs from the graph, then beta AC is equal to 150. In this example, a low input to the transistor gives a high output and a high input gives a low output. The switching conditions are designed such a way that the transistor does not stay in the active state. The output characteristics graph for a transistor gives us the relation between the collector current and emitter voltage. It also gives us the value of base current, but it gives no information about the base emitter voltage. Amplification factor is equal to IC upon IB, small change, and VC is constant, that is current gain is equal to IC into IB. VC is constant. Transistor consists of two PNP in the series of PNP and NPN. Number of depletion layers in a transistor is 2. A transistor made up of two PN diodes connected back to back. Collector is the biggest component in the transistor. In PNP transistor, majority charge carriers are holes and minority charge carriers are electrons. Transistor is a current driven device since the IC is controlled via IB, that is collector current is controlled via base current. In NPN transistor, holes are the minority carriers and free electrons are the majority carriers. Base current is typically 1 to 5% of the emitter current or collector current for small signal transistors. Since transistors have a constant current source in the emitter circuit, the input impedance is very high. In common emitter circuit, IE is equal to IC plus IB. IE is equal to IC, therefore, ratio of IC upon IE is always less than 1. So alpha is less than unity. Its value lies between 0.9 to 0.995. The most commonly used transistor arrangement is common emitter arrangement. In BJT, base region is sandwiched between emitter and collector. BJT operates in active region to work as amplifier and oscillators. In transistor, base is very lightly doped as compared to the emitter. Because by doing so, IB is high, recombination is decreased in the base region. Input signal is applied between the base and emitter terminals. Input current flowing is the IB and hence characteristics are represented by a plot between VB and IB. If the collector base junction is reversed bias and base emitter junction is forward bias, then BJT functions in the active region of the output characteristics. If collector base junction and the base emitter junction are both forward bias, then BJT functions in the saturation region of the output characteristics. If the collector base junction and the base emitter junction are both reversed bias, then BJT functions in the cutoff region of the output characteristics. The transistor in which one N-type material is doped with two P-type materials, such type of transistor is known as PNP transistor. Base will be of N-type material. In transistor, 1N and 2P type materials doped in PNP transistors. In common base amplifier, input signal is applied at emitter terminal while the amplified output signal is obtained at the collector terminal. With respect to ground, for AC signals, the base collect terminals is specifically connected to the ground through the capacitor. Even output resistance is very high and hence the current gain is approximately equal to unity. Due to this, there is no possibility of current amplification. Consequently, the CB amplifier exhibits high voltage gain. In common collector configuration, also known as emitter follower, because the emitter voltage follows that of the base, offering a high input impedance and a low output impedance. It is extensively used as a buffer. Voltage gain is unity. Even though current gain is high, the input and output signals are in phase. In common base configuration, input impedance is low while output impedance is high. Although voltage is high, the current gain is low and overall power gain is also low. When compared to the other transistor configuration available, thus there is no current amplification because of unity current gain. In cutoff region, both the junctions are reversed bias. Transistor has practically zero current because the emitter does not emit charge carriers to the base. There is negligibility current due to minority carriers. In this mode, transistor act as an open switch. In saturated region mode, both the junctions are forward bias. The negative terminal of the battery is connected to the emitter. Collector current becomes independent of base current. In this mode, transistor act as a closed switch. Depending on the type of load, a collector current is induced that would turn on the motor or LED. Transistor in the circuit is switched between cutoff and saturation, the load. For example, can be a motor or a LED light emitting diode or any other electrical devices. Output devices like LEDs only require a few milliampere at logic level DC voltage and can therefore be driven directly by the output of a logic gate. However, high power devices such as motor or lamps require more power than that supplied by an ordinary logic gate. So transistor switches are used. Therefore, LED driven by transistor logics. LEDs output devices only require a few milliampere at logic DC voltages. From the cutoff characteristics, the base emitter voltage in a cutoff region is less than 0.7 volt. The cutoff region can be considered as off mode. Here VB is greater than 0.7 and IC is equal to 0. Here transistor will be biased so that maximum amount of IB is applied, resulting in maximum IC, resulting in minimum emitter voltage drop, which results in depletion layer as small as possible and maximum current flows through the transistors, therefore decreases by decreasing emitter voltage drop. From the saturation mode characteristics, the transistor acts as a single pole, single throw solid state switch. A zero IC flows with a positive signal applied to the base of a transistor. It turns on like a closed switch. Therefore, VB is saturated region cannot be predicted. Sometimes DC current gain of a BJT is too low to directly switch the load current or voltage. So multiple switching transistors is used. The load is connected to the ground and transistor switches the power to it. Thus switching power with PNP transistor is sourcing current and NPN transistor is sinking current. BJT, three semiconductor diode regions, emitter, base and collector region, and operates at defined region of cutoff mode, active mode and saturation mode respectively. A BJT operates as an amplifier in active mode and a switch in cutoff or saturation mode. In cutoff mode, there is no current flowing through the BJT, hence both junctions BE and CE must be reversed bias, else if either of them is forward biased, then the current will flow. Collector current depends linearly of saturation current and exponentially to the ratio of voltage between difference of base and collector and thermal voltage. In the physical mode of a common base transistor amplifier, the input is measured at the emitter terminals of the BJT biased device, whereas output is measured across collector terminal of it. To determine the input characteristics, the VCB is kept constant at 0 volts and VEB is increased from 0 volts to different voltage levels. For each voltage level of the input voltage, the input current is recorded. And to determine the output characteristics, the IE is kept constant at 0 current and VCB is increased from 0 volts to different voltage levels. For each voltage level of the output voltage, the IC current is recorded. The dynamic input resistance, that is Ri, is equal to smallest change in VB upon smallest change in IE, keeping Vc constant. Here IC is equal to beta into IB. Therefore, IC will be 2.5 milliampere in this example. When no voltage is provided at the base, then no current passes through or from emitter to collector. So, even if very high potential difference is applied to the emitter collector junction, no current flows through it. This configuration is used for the switching in various appliances using BJT. BC547B, that is BJT, most common and widely used NPN transistor. It is small, cheap uses less power and fulfills most of the requirement for general purpose use. In BJT, both electron and holes are responsible for conduction. The term bipolar itself means two polarity, which represents that both charged particles are responsible for the conduction in the BJT. A BJT has two p-n junction. First p-n junction is between the base emitter terminal and second p-n junction is between base collector terminal. A base is always between emitter and collector. 0.7 is the minimum voltage required to make the base emitter junction of a real silicon bipolar junction transistor in forward bias. This 0.7 volt potential difference between base and emitter terminals takes the p-n junction in forward bias. Collector to emitter voltage and IC are the parameters considering which transfer characteristics curve of BJT is made. It is voltage versus current graph in which current lies on y-axis and voltage lies on x-axis. Here IC is equal to beta into IB, that is 0.8 milliampere in this example. FET, field effect transistors, are voltage controlled devices. By applying some voltage between the gate and source, the drain current can be controlled. In order to control the operation of FET, the gate to drain voltage is varied to operate the FET in different regions of operation. Because of the silicon dioxide insulator doped between drain and source at the top, the resistance offered by this is very high. The insulator will stop the flow of electron from one part to another, which acts as an open circuit. BJT is usually built with a thickness of up to 1 cm, whereas FET uses a fabrication technique which makes its size in mm. Therefore, BJT is larger than FET in size. Because of its small size, the IC chips can be made even smaller, which reduces the wear and tear. The process technology used with constant at which the ratio of width and length the FET is made more advantageous. For FET, the current reaches maximum, that is IDSS, occurs when VGS, that is gate source voltage, is 0 voltage and drain source voltage is greater than or equal to Vp. When the gate to source voltage is less than pinch off, both the junctions will be reversed biased and hence no current flows. ID is equal to IDSS 1 minus VGS upon Vp 2. If Vp is equal to VGS, then ID is equal to 0 ampere. By varying the gate to source voltage, resistance can be varied as follows. Rd is equal to R0 upon 1 minus V2GS upon Vp. Therefore, FET as voltage controlled resistor in ohmic region. When a voltage greater than pinch off is applied, the current starts flowing from drain to source for N channel FET, and for P is vice versa, that is source to drain. The forward bias drain and gate is the reason for the flow of electron from drain to source. As the conventional current flows opposite to the electron flow, the current will flow from source to drain in P-type channel FET. FET are unipolar transistors as they involve single carrier type operation. FET's conductivity is regulated by the voltage applied to a terminal, the gate, which is insulated from the device. In fact, the current enters the channel through source and current leaves the junction through drain. Other than the three terminals, source, drain and gate, there is a fourth terminal called as a body or base. This is used to bias the transistor to operation on. In fact, the width is greater than the length of the gate. Length gives the distance between source and drain. Width is the extension of the transistor in the direction of particular to cross section. Gate permits the electron to flow through or block their passage by creating or eliminating the channel between source and drain. In n-channel depletion mode device, as the depletion layer region width expands, it encroaches the channel from the sides and channel becomes narrow. A positive gate to source voltage increases the channel size and allows the electrons to flow easily. Saturation mode, which is in between the ohmic and saturation region, is used when amplification is needed. The FET physical structure, which contains silicon dioxide, provides infinite resistance. Hence, no current will flow through the gate terminal. Ig is equal to 0 ampere. For a FET, same current flows through the gate and source terminal. Hence, source current is equal to 1 milliampere. Here VDS is equal to VDD minus VDRD. Therefore, in this example, RD is equal to 2 kilo ohm. FET, monopolar devices with only one carrier type, either electron or holes, providing current flow through the device. N-channel FETs employ electrons, while P-type channel FETs employs holes as a source of current. The current flows in the device is due to the majority carriers. In an N-type JFET, it is due to the electrons, and in a P-type JFET, it is due to the holes. The pinch off voltage for an N-channel JFET is negative, that is not greater than 0. The depletion region would extend into the N-channel if the reverse bias in the gate to source voltage increases, which means the gate to source voltage has to be negative since the gate is N-type, and in N-channel is always on depletion mode JFET. Since the channel for current flow from source to drain is always present, this is in contrast to P channel JFET, which needs to be provided with a channel for the flow of current. A JFET has three terminals, namely source, gate, and drain. The gate source PN junction is always reversed bias because if it is forwarded, then all the current of channel will flow to the gate and not to the source, ultimately damaging the JFET. A common base configuration of a PNP transistor is analogous to common gate configuration of a JFET. When drain voltage is equal to pinch off voltage, the depletion layers almost touch each other. IDSS is referred to as the drain current for zero bias because the gate source voltage requires no bias voltage to operate. The gate source voltage is just zero. No voltage needs to be applied to it. IDSS, drain to source current with gate shorted. A JFET has high impedance. Input impedance is high because input is reversed bias. A JFET is properly biased condition acts as a voltage controlled current source. The input resistance of a FET is typically very high in order of mega ohms, that is up to 100 mega ohm. FET is a voltage driven controlled device, that is the output current is controlled by the electric field applied and it is three terminal device. Unlike MOSFET metal oxide semiconductor field effect transistors. JFETs are predominantly depletion mode devices. JFETs are predominantly depletion mode devices, meaning they are normally on and require a gate source voltage to turn them off. A physical structure and doping of JFETs make it difficult to achieve enhancement mode operation. Usually, the semiconductor diode of choice is silicon. Some chips manufacturers, mostly notably IBM and Intel, use an alloy of silicon and germanium SiG in MOSFET. Thank you. Transistors Unit 5. Sensors and transducers Unit 6. An ideal transducer should show high linearity. A linear system should produce exact output AC to input and high dynamic range, repeatability, and low noise. Active transducers, that is thermocouple, are self-generating type. They don't require external power to work, while passive transducers require external power to work, like LVDT. Self-generating transducers, that is active transducers, is due to property of working without the use of external power. Analog transducer converts physical quantity to analog quantities, while digital transducers converts physical quantities to analog, that is analog quantities to digital signals. Strain gauge is an example of an analog transducer. Linear variable differential transformer (LVDT) is a type of transformer which is used for measuring displacement, and it has the same principle of operation of transformer, that is mutual induction. Piezoelectric crystals produces an electric signal when pressure applied. For example, are quartz, Rochelle salt, that is it converts force into electrical signals. Capacitive transducers converts measurand into changes in capacitance. Change in capacitance is caused by change in dielectric or change in distance between plates, that is dynamic measurement. Photoconductive action is the property of reduction of resistance when exposed to light. Selenium shows the photoconductive action. Transducers are devices that converts energy from one form to another. This energy can be either mechanical energy, light energy, or any other form of energy. Active transducers do not require any additional power supply for converting energy from one form to another, as they work on the principle of energy conservation, that is thermocouple. The piezoelectric transducers converts mechanical to electrical energy. They are generally used to detect the knocks or any impulsive force. They are also used in electric drum pads to detect impulse provided by the drumsticks. The LM35 IC manufactured by Texas Instruments is used as a temperature sensor. The output voltage generated by these ICs is linearly proportional to the temperature in centigrade. The output voltage is directly proportional to the temperature. Ultrasound produces the ultrasounds in a wide range of application in many fields. Ultrasonic transducers produces frequency rating from 20 kilohertz to several gigahertz. Ultrasounds have a wide range of application in many fields, but majorly they are used for measuring the distance of objects. LVDT is a displacement transducer that converts rectilinear motion to the electric signal. They are used widely due to their robustness. When light falls on LDR, light dependent resistor, its resistance changes. It is inversely proportional to the intensity of light. When light falls on LDR, the resistance decreases and more current starts to flow through it. It is used to measure the intensity of light. Hall effect transducers or sensors is used to measuring the magnitude of the magnetic field. The output voltage produced by the sensor is directly proportional to the strength of magnetic field passing through it. The inductive transducers can be used for measuring displacement and thickness of thin plates. Inductive potentiometer has same function as linear potentiometers and is used for measuring displacement. Capacitance of a material is affected by area and distance of separation of plates and dielectric material. Strain to be measured is applied to the parallel plates of a capacitor and total displacement change will be proportional to the strain. Capacitive transducers application in measurement of both strain and pressure and angular displacement to find out. Hence, all the capacitive strain gauges, tachometers, and pressure transducers can be treated as application of capacitive transducers. Capacitance C is equal to epsilon 0 epsilon r A upon T, where A are dielectric constant, area of plate A, and D is the distance between plates. Decrease in distance between plate and all other factors are constant. Capacitive transducer finds application in measuring almost all quantities like displacement, thickness, moisture, speed, temperature, as in way moisture measurement. Piezoelectric effect was first invented and explained by the Curie brothers, Pierre Curie and Jacques Curie in 1980. Quartz, ADP, ammonium dihydrogen phosphate, and bernalite are examples of piezoelectric materials. Piezoelectric transducers can be used to measure a wide range of quantity like pressure, acceleration, strain, displacement, etc. For a piezoelectric strain transducer, as the strain applied increases, the output voltage also increases. Voltage is directly proportional to the strain. Photoelectric devices are sensitive to certain wavelengths only, hence they should be calibrated before every use. In photoemissive transducers, electrons emitted by the cathode are attracted by anode plates. The quantities that can be measured are called as physical quantities or measurand. A passive transducer is an externally powered transducer. This device cannot convert a physical signal into an electrical signal on its own to another energy source. The passive element, when connected, it transforms the motion by the fluctuations generated from the power supply which being recorded. Photoconductive cells are materials which conductivity on the application of light, that is materials of selenium, silicon and germanium. Photojunction diodes are semiconductor layers formed by silicon and germanium which are used in photovoltaic cell. Phototransistors are formed by placing two photodiodes back to back. Thermocouple is a device which converts thermal energy to electrical energy, and it can be treated as a primary device. Operation of thermocouple is based on three major effects: Peltier effect, Thomson effect, and Seebeck effect. All describes the relation between current flow and temperature between two different metals. Immersion type thermocouple can be used to measure temperature of liquid in which thermocouple is immersed in liquid. Active transducers can be subdivided into four parts: photovoltaic, thermoelectric, piezoelectric, electromagnetic. Active transducers are also known as self-generating type of transducers. They develop an electrical voltage or current proportional to the quantity being measured. Passive transducers develop electrical signals by means of an external source. They are usually known as externally power driven sources. In capacitive transduction, measurand involves the change between the capacitance. It changes when distance between the plates is varied or by the change in a dielectric. Electromagnetic transduction involves the conversion of the measurand into electromotive force. Magnetic flux is produced as a result of relative motion between the magnet and an electromagnet. In an inductive transduction based system, measurand involves changes in the self induction of the coil. In a photovoltaic transduction based system, measurand is converted into voltage when the junction between dissimilar elements is illuminated. Voltage generation through light. Analog transducers converts input into analog signals. The output is a continuous function of time. Strain gauge, LVDT, thermistors, etc. are analog transducers as they produces outputs which are a continuous function of time. An inverse transducer is used to convert electrical quantity into a physical quantity. For example, loudspeakers convert electrical signals into sound signals. Digital transducers produce digital output in response to an input signal. A unique code is generated for each discrete value sensed. A transducer is selected based on the nature of the quantity that is being measured. For example, temperature measurement involves the use of temperature sensors, whereas measurement of stress involves a strain gauge. Transducers should operate under strong magnetic fields. Generally, transducers with a low value of output impedance, high value of output voltage, and shorter cable length are not susceptible to such interference. There are three passive transducers, that is resistive, inductive, and capacitive transducers. Smallest change which a sensor can detect is resolution. Thermocouple is a device which is capable of producing output voltage AC to input temperature. Sensor is a device which enables measurement of input value. Potentiometers for sensing resistors and accelerometers are analog sensors. The thermistor is a thermally sensitive resistor that exhibits a large, predictable, and precise change in resistance correlated to variation in temperature. A resistance thermometer measures temperature by correlating the resistance of the RTD with temperature. An RTD consists of a film or For greater accuracy, a wire wrapped around a ceramic or glass core. Thermocouple consists of two different metals connected at 2 points. The varying voltage between these 2 points reflects proportional changes in temperature. A semiconductor-based temperature sensor is placed on IC. They are linear but have the lowest accuracy. Semiconductor PN junction diode is photodiode. It is always operated in the reversed bias condition. The light is always focused through a glass lens on the junction of the photodiode. Output transducers are which converts electrical quantity into non-electrical quantities, known as inverse transducers. Transducers are devices which transfers measurand which will be an non-electrical quantities to electrical quantities. Inverse transducers are the devices operating just opposite to the transducers, that is electrical to non-electrical quantities itself. Piezoelectric transducers are devices which are capable of converting electrical quantities to non-electrical quantities, which is an inverse transducers. Quartz, barium titanate, and lead zirconate are piezoelectric substances acting as inverse transducers, and cadmium is not inverse transducer. Passive transducers are transducers that require energy to translate changes due to the measurand. Active transducers converts one form of energy into another. For example, photovoltaic cell in which light energy is converted into electrical energy and works on the principle of energy conversion and do not require any power to operate. Accuracy describes the algebraic difference between the measurand's true or theoretical value or indicated value. Resolution is the ability of the transducer and sensors to see small differences in reading. Precision refers to the degree of repeatability of a measurand. Threshold of the transducer is the smallest change in measurand that will result in a measurable change in the transducer output. Offset is the output that will exist when it should be zero. Linearity shows closeness of the transducer's calibration curve to a specific straight line which in a given percentage of full scale output. Noise is the unwanted signal at the output due to either to internal sources or interference. Linearity reflects that output is in some way proportional to the input. A linear sensor proportionally produces output to input. Photoelectric transducers converts light energy by causing the radiation to fall on a photosensitive element and measuring the electrical current so generated with a sensitive galvanometer directly or after suitable amplification into electrical current. Photovoltaic or barrier layer cells usually consist of a semiconducting substances, which is generally selenium, deposited on a metal base, which may be iron, and acts as one of the electrodes. The semiconducting material substance is the cover with a thin layer of silver or gold deposited by cathodic deposition in a vacuum. This layer acts as a collecting electrode. Photodiode is a PN junction semiconductor diode. It always operated in the reversed bias condition. The light is always focused through a glass lens on the junction of the photodiode. Photovoltaic cells are very robust in construction, need no external electrical supply, and produce a photocurrent sometimes stronger than other photosensitive element. Typically, photocurrents produced by these cells are as high as 120 milliampere per lumen. At constant temperature, current sets up in the cell usually shows a linear relationship with the incident light. Thermistors is used to measure temperature. It is a temperature transducer. With a change in temperature, its resistance changes. Thus, in its working principle is variable resistance. Thermistors are the oxides of a certain metals like manganese, cobalt, and nickel, which have large negative temperature coefficient. That is, resistance decreases with the increase in temperature. Output transducers, which are converts electrical quantity to non-electrical quantities, known as inverse transducers. For example, piezoelectric transducers. Thermocouples have the wide range of temperature measurement from minus 184 degrees Celsius to plus 230 degrees Celsius, that is 2300 degrees Celsius. RTD has a range of minus 200 degrees Celsius to plus 850 degrees Celsius. Thermistor has a range of 0 degrees Celsius to 100 degrees Celsius, minus 37 degrees Celsius to 356 degrees Celsius is conventional mercury thermometers, that is a G thermometers range. Thermocouple is a active transducers. The junction at a higher temperature is thermocouple is termed as measuring junction. The junction at lower temperature of in thermocouple is referenced as a reference temperature. Cold junction is usually kept at 0 degrees Celsius, lower temperature junction at 237 Kelvin or 0 degrees Celsius. When two wires of a different material are joined together at either end, forming two junctions which are maintained at different temperatures, a thermomotive force is generated, causing a current to flow around the circuit. This arrangement is called as a thermocouple. RTD, resistance temperature detector device, is a passive sensor and requires current excitation to produce an output voltage. RTD has very low temperature coefficient. Voltage drop across RTD is much larger than thermocouple output voltage. LVDT, linear variable differential transformer robustness, is a type of transformer used for measuring displacement by rectilinear motion to electrical signals, and it has the same principle of operation of transformer. Piezoelectric crystals produces an electrical signal when pressure is applied, for example quartz, rochelle, salt, that is, it converts mechanical force into electrical signal. Capacitive transducers converts measurement into changes in capacitance, which is caused by change in dielectric or change in distance between plates. Photoconductive action is the property of reduction of resistance when exposed to light. Selenium shows photoconductive action. Piezoelectric transducers converts mechanical energy to electrical energy by detecting a knock or an impulsive force. They are also used in electronic drum pads to detect the impulse provided by the drum sticks. The LM35 IC manufactured by Texas Instruments is used as a temperature sensors. The output voltage generated by this IC is linearly proportional to the temperature in centigrade. When light falls on LDR, light dependent resistors, its resistance changes inversely proportional to the intensity of light. That is, when light falls on LDR, resistance decreases and more current flows through it, used to measure the intensity of light. Hall effect transducers or Hall effect sensors is used for measuring the magnitude of the magnetic field. Output voltage is directly proportional to the strength of magnetic field passing through it. Thank you. Sensors and